Name each polynomial by degree and number of terms. Let's write out some of these names, shall we? That's how you spell degree. If something has a degree of 0, it's constant. If something has a degree of 1, it's linear. If something has a degree of 2, it's quadratic. If something has a degree of 3, it's cubic. If something has a degree of 4, it's quartic. And if that's not how you spell quartic, and if something has a degree of 5, it's quintic. If there's one term, it's a monomial. If it's two terms, it's a binomial. It's supposed to be a B. And if it's three terms, it's trinomial. Anything higher than a 5 degree, we really don't name. Anything higher than a 3 degree, we really don't, or 3 term, we don't name. We'll call it like a 4 term quadratic or something like that. But let's see what we have here. The degree is the highest exponential value attached to a variable. Negative 10x has an exponential value of 1 attached to a variable. So there's one term and a degree of 1. This is a linear monomial. This has no variable, which means the degree is 0, which means it's constant. It's a constant monomial because there's one term. Constant monomial. You have 1, 2, 3, 4 terms, and the highest degree is 3. So this is a cubic 4-term polynomial. So there's a few for you. Simplify, parentheses, 5 plus 7x cubed plus 3x squared, close parentheses, plus parentheses, negative 12 plus 5x plus 6x squared, close parentheses. When there's no anything in front of a parentheses or just a plus sign in front of parentheses, you don't need them. Get rid of them. 5 plus 7x cubed plus 3x squared plus negative 12 plus 5x plus 6x squared. Let's go in order of highest degree. We have a 7x to the third. There's nothing else like 7x to the third, so don't combine 7x to the third with anything. 3x squared plus 6x squared is going to be 9x squared. 5x all alone by himself. And then you got 5 and negative 12, which make negative 7. So there you go. We simplified. We combined like terms. Simplify this parentheses minus that parentheses minus that parentheses. Well, when you have nothing in front of the parentheses, you don't need it. So this is negative 10mn cubed minus 4n to the fourth. When you have a negative in front of parentheses, you distribute the negative. So everything inside the parentheses gets its sign flipped. So plus 2n to the fourth plus 7mn cubed plus 6n to the third. Same thing happens here. Distribute the negative. Minus 5n cubed minus 6mn to the third. All right. In no particular order, let's just start out with the mn to the thirds. So there's a negative 10mn to the third, a positive 7mn to the third, and a negative 6mn to the third. When you have like terms, add up the coefficients, but keep the variables the way they are. Negative 10 plus 7 is negative 3. Negative 3 minus 6 is negative 9. So negative 9 mn to the third. Now we got negative 4n to the fourth. We got positive 2n to the fourth, and nothing else like those. So negative 4 plus 2 is negative 2, and n to the fourth comes along for the ride. These guys are also next to each other. So negative 6n cubed, regular 6n cubed, minus 5n cubed is just plus 1, or invisible 1, n cubed. And that's our guy. Ooh, a FOIL problem. Curses. Get it? Because of FOILed again? FOIL means you're going to multiply the first term, so 2n squared. You're going to multiply the outer term, so 2n times negative 2 is negative 4n. You're going to multiply the inner term, so plus 3n, and you're going to multiply the outer term, so negative 6. Okay, FOIL problem is when you multiply a binomial times a binomial. Usually when this happens, not always, but usually you combine like terms. So this negative 4n and that positive 3n become negative n, and 2n squared and minus 6 drop down and come along for the ride. Ooh, look at this extended FOIL problem. You're going to have a lot of distributive property. What's going to happen is, since we have a trinomial times a trinomial, we're going to focus on the first term of this trinomial and distribute that to all three of those guys. So x squared times negative x squared is negative x to the fourth. X squared times positive 3x is positive 3x cubed. And x squared times negative 5 is negative 5x squared. Now let's do the same exact thing with the negative 2x. Multiply that negative 2x to all three terms in the other parentheses. Negative 2x times negative x squared is positive 2x to the third. Negative 2x times positive 3x is negative 6x squared. And negative 2x times negative 5 is positive 10x. Do it one more time. Negative 8 times negative x to the second, 3x, and negative 5. Negative 8 times negative x squared is positive 8x squared. Negative 8 times positive 3x is going to be negative 24x. And negative 8 times negative 5 is positive 40. Now, there's going to be combining like terms. Is there anything like negative x to the fourth? Nope. Is there anything like negative or regular 3x cubed? Yep. How about 2x cubed? Okay, combine those, and that gets you 5x cubed. Is there anything like 5x squared, negative 5x squared? Sure, negative 6x squared and positive 8x squared. So negative 5 minus 6 is negative 11. Negative 11 plus 3 is negative 3. Bring x squared along for the ride. 10x is just like negative 24x, which is going to be 10 minus 24 is negative 14. Carry along the x. And 40 is all alone by itself. So let's add 40. And that is going to be that. Fun. X cubed plus 125. We have to factor that. Oh, this is called a sum of cubes. The formula for sum of cubes is a cubed plus b cubed factors out to a plus b times the quantity a squared minus ab plus b squared. Now, you might look at this and say, well, this doesn't look like this. Not yet. But if I were to turn this 125 into 5 to the third, then you can see the sum of cubes. So you're my a and you're my b. Let's put it together. X plus 5, x squared minus x times 5 plus 5 squared. Now it's a matter of cleaning this up a little bit. X plus 5 times the quantity x squared minus 5x plus 5 squared, which is 25. That, boys and girls, is sum of cubes. Ooh, we have difference of cubes. And if you're looking at this and saying, no, oh, that's not a cube, buddy, negative 27 is negative 3 cubed. That's a difference of cubes. Now, what's the formula for difference of cubes? A cubed minus b cubed can be factored out to a minus b times the quantity a squared plus ab plus b squared. So x would be my a, and 3 would be my b. Okay, so this becomes, and let me not use green because green doesn't show up that well, a is x minus b is 3 times a squared, which is x squared, plus a, which is x, times b, which is 3, plus b squared, which is 3 squared. Now let's clean that up. X minus 3 times x squared plus x times 3 is 3x plus 3 squared is 9. That is going to be your factored answer. Factor 12a cubed minus 9a squared plus 4a minus 3. We are going to factor this by grouping. What we're going to do is we're going to group the first two terms in parentheses like so. Make sure there's a plus sign in between, and group the last two terms in parentheses like so. Factor each parentheses. I have a 3 and an a squared in common. So if I factor out a 3a squared out of u, that leaves me with 12 divided by 3 is 4. Take away 2 a's from 1a. 3 a's is 1a. Minus 3, 3. Take away both a's is that. Okay? Now it also just so happens that we already have the parentheses for a minus 3. So what I have here is something times 4a minus 3 plus invisible 1 times 4a minus 3. Why don't I factor out the parentheses? And when I factor out the parentheses, that leaves me with 4a minus 3. And what I have left over after I factor out the parentheses is 3a squared plus 1. So this factors out to that. You can't do anything more, you can't do anything more, we are finished. Factor 35xy minus 5x minus 56y plus 8. We are going to do this by factoring by grouping. The way you factor by grouping is you put the first two terms in a set of parentheses, like so, and you put the second two terms in a parentheses, the last two terms, I guess I should say, like so. Don't forget that y, always with the plus sign in between. Now factor each parentheses on its own. I can pull out a 5 and I can pull out an x. So let's pull out a 5x. When I do that, I am left with 7y minus 1. The second group of parentheses, I can factor out a negative 8. Now I'm factoring out a negative 8 because I want this to look like that. If I pull out an 8, it's going to leave me with negative something. But if I pull out a negative 8, like that, then that's going to make it a little bit better. So if I factor out a negative 8, dividing negative 8 from negative 56y is going to be 7y. How about that? Minus 1, because 8 divided by negative 8 is negative 1. Now I've noticed, oh, wait a minute. I have the same parentheses in common. Let's factor that out. So I have 7y minus 1. That is now factored out. And after factoring that out, I'm left with 5x minus 8. You take a look at what you have. You realize I can't factor either of these anymore. I am done. I am done. I had lots and lots of fun. Factor a to the fourth plus 6a squared plus 5. Well, I don't like a to the fourths, I don't like a squareds, but you know what this kind of looks like? This looks like it could be quadratic. So this is what I'm going to do. I'm going to make believe that a squared is just regular x, just for a minute. I'm going to make believe that a squared is x, which means the 6a squared in the middle is going to be 6x. So a squared, oh, that becomes x squared because there's 4. Okay, that makes sense. So I'll call you x squared plus 6x plus 5. You should look at that and say, oh, well, now that's a quadratic. And two numbers that add up to 6 and multiply out to 5 are going to be 5 and 1. So you have x plus 5, x plus 1. Now, before we finish, we didn't start out with x. We started out with a. And we called a squared x. So I have to turn x back into a squared. So you're a squared plus 5, and you're a squared plus 1. I look at what's left over on the inside. You can't factor any of that anymore. We are done. Well, this is going to be annoying. Factor 5x to the fourth minus 9x squared plus 4. First things first. This is a quartic that looks quadratic. How do I know that? Because you're x to the fourth, you're x squared, and you have nothing. So what I'm going to do is I'm going to go over here and I'm going to say, let's let x squared be the same as a. So now you are 5a squared minus 9a plus 4. And you're like, oh, yeah, now that looks quadratic. Good job. Now, this is one of those things where the Nick Parrish way or the math teacher goat way of doing this, I like to kind of split this up into different combinations. I like to find out what possible numbers you can multiply out to 5, so I'll write out 1 and 5. Now, this is negative 9 here, so the possible combinations that multiply out to a 4, right, that also add up to a negative 9 are both going to be negative. So one possibility is going to be negative 1 and negative 4, or negative 4 and negative 1, or negative 2 and negative 2, And fortunately, those are the only options. Now, the Nick Parich way of doing this, as opposed to other ways of doing these types of factoring where the first coefficient is not 1, I like to pick numbers and multiply the insides and then multiply the outsides. I like this one. Okay, if I multiply the 1 to -4, that gets me -4. If I multiply the 5 to -1, that gets me -5. That adds up to my -9. So the combination that works for me is 5, 1 and -4, -1. So I'm going to build my parentheses based off of that information. 5 and 1 are attached to my a's. So 5 is going to be here, 1 is going to be here. Okay, -4 and -1 are attached to my constant, so I'll put -4 here and -1 here, right? In that order. Now, you could look at this and say, I don't need that 1 there. Great. So if you write out 5a minus 4 and regular a minus 1, you're not good enough. Why? There's no a's in the original problem. Remember, a is x squared, so my final answer is going to be 5x squared minus 4 times the quantity x squared minus 1. And you take a look at that, and you might be happy and think that you're done. But wait a gosh darned minute. X squared minus 1, that's difference of squares. So I can't do anything with 5x squared minus 4, but x squared minus 1 actually factors out to x plus 1, x minus 1. So let me write that up here where I have a little bit more space. Okay, my final answer, 5x squared minus 4, can't do anything about that. Now, if that was x squared minus 4, we could, but that 5, then you got x plus 1, then you got x minus 1. That's going to be our final answer. Ooh, I love those problems. Fun stuff. Factor x to the 6th minus 9x to the 3rd plus 8. You might be looking at that and saying, that looks quadratic. You're absolutely right. It does. See how that's x to the 6th and that's x to the 3rd? We could just say, let's let x to the 3rd be the same as, I don't know, a. And once I do that, we can turn u into a squared minus 9a plus 8. And now it looks quadratic. And our job here is to come up with two numbers that add up to -9 and multiply out to +8. Okay, now when I do that, two numbers that add up to a negative and multiply out to a positive are going to be a negative and a negative. And if I do 8 and 1, I'm in great shape. This is going to be fun. You'll see why. Now, A and A, I've completed this part. However, I'm not done yet because A is not in the original problem. We let A equal x cubed. So this is x cubed minus 8, and this is x cubed minus 1. Now, if you're looking at your work and you're happy and you're proud, good. And if you circle it, though, bad, because I have news for you. You're not done yet. This is difference of cubes. So x cubed minus 2 cubed and x cubed minus 1 cubed. We're not done yet. Both of these are difference of cubes, which means we're going to have parentheses, bigger parentheses, parentheses, bigger parentheses. So let's write up here what our difference of cubes formula is. All right, so let's change colors. The difference of cubes formula is if I give you something like a cubed minus b cubed, that's going to end up being a minus b times the quantity a squared plus ab plus b squared, close one, plus b squared. So this first one, all right, let's do in blue. You would be my a, you would be my b. So you're going to be x minus 2 times the quantity x squared plus x times 2 plus 2 squared. Now we'll clean that up in a little bit. Okay, the second group of parentheses, you would be my a, you would be my b, is going to be a minus b, so x minus 1 times the quantity a squared, so that's going to be x squared plus ab, so x times 1, plus b squared, which is 1 squared. Okay, so looking at it one parentheses at a time, I don't have to clean you up too much. X minus 2, x squared plus 2x plus 4, x minus 1, x squared plus 1x plus 1. Lots and lots and lots of factoring. Who would have thought that that actually factors out to that? Isn't that pretty? Factor x to the 6th plus 2x to the 4th minus 16x squared minus 32. Whenever I'm asked to factor something and there's 4 terms there, I'm thinking factor by grouping. You take the first 2 terms, group them in their own set of parentheses. So x to the 6th plus 2x to the 4th. You take the second group of terms and you put those in its own set of parentheses. So negative 16x squared minus 32, always a plus sign in the middle. Okay, always a plus sign in the middle. Now you take a look at the first parentheses and see what you can factor out. It looks like I can factor out an x to the 4th, and that leaves me with x squared plus 2. Here, it looks like I can factor out a negative 16x squared. Nope, negative 16x, just negative 16. I don't know why I put x squared there. Sorry. Negative 16. Oh, that's going to make this fun. And then that leaves me with, sorry, multitasking, looking for the colors that I need. I need red. So if I pull out that 16, or x squared plus 2 again. All right. So it looks like in common in both of these groups, I have an x squared plus 2, so let's pull that out. Okay, now what I'm left with here is x to the 4th minus 16. Okay, now I'm not done. Because if you're looking at that and thinking difference of squares thoughts, you're absolutely thinking correctly. I'm going to, now let's just do this. Okay, keep it nice and clean. Let's just focus on the x to the 4th minus 16 over here. Okay, x to the 4th minus 16. That looks like it should be difference of squares because it is. So what I have technically is x squared minus 4 squared. That's difference of squares. So what that becomes is x squared minus 4 x squared plus 4. Okay, now looking at this, you should be able to say, well, wait a minute. X squared minus 4 is more difference of squares. That's x plus 2, x minus 2. Can I do anything with that? No. There's no sum of squares. So this guy in purple becomes that guy. So my final answer is going to be x squared plus 2, x plus 2, x minus 2, x squared plus 4. And that's something. It's pretty stuff. Find the zeros of f of x equals 2x minus 1 in parentheses and x minus 5 in parentheses. All right, well, finding the zeros is another way of saying let f of x equals 0, and we have zero product property going on here, like so. The only thing I did is I let f of x equals 0. Zero product property says if you have a times b, or two things or more multiplied together and it all equals 0, set each of those factors equal to 0. So this times that equals 0, which means this equals 0 and that equals 0. And it's just a matter of you solving both of them individually. So the guy on the left, I add 1, like so. 2x equals 1. Divide by 2, divide by 2. X equals 1/2. That's one option. This guy you add 5, and of course you probably could have looked at this and said, oh, that's just x minus 5, so the answer is going to be x equals 5. And if you thought that correctly. So that's my second option. So my zeros are going to be x equals 1/2 and also x equals 5. And that is how you do it. Find the zeros of f of x equals x times parentheses x plus 2 times parentheses x minus 2 times parentheses 3x squared minus 4. This involves the zero product property. Whenever you're asked to find the zeros, you turn f of x equal to 0. Okay, let me give myself a little bit of space for all of this. Now, this is zero product property. Zero product property says if you have two things or more multiplied together, you set each thing equal to 0. Okay, if you have two or more things multiplied together and it's equal to 0, each thing equals 0, which means x equals 0. So I'm done. x plus 2 equals 0, x minus 2 equals 0, and 3x squared minus 4 equals 0. Okay? So for this, subtract 2, cross you out. X equals negative 2, that's my second possible answer. For this one, add 2, cross you out. X equals 2 is my third possible answer. This one's going to require a little bit of work. So for this one, I don't know why I put an arrow there. 3x squared, I'm just going to rewrite it out. Add 4 to both sides. So 3x squared equals 4. Divide by 3, cross you out. X squared equals 4 over 3. Now, in order to get rid of the squared, you square root both sides. Don't forget your plus or minus. Not done yet. This leaves me with x equals plus or minus. Square root of 4 is 2 over root 3. Now, you know you're not allowed to have the square root of 3 on the bottom. So you multiply the top and the bottom by the square root of 3. That gives you 3 on the bottom, and on the top 2 root 3. So x is going to equal positive or negative that. Okay, so my 5 answers are going to be x equals 0, negative 2, positive 2, plus or minus 2 root 3 over 3. And that's how it's done. Find the zeros. Well, whenever you're asked to find the zeros, that means you set f of x equal to 0 and go from there. Now, whenever you have a polynomial, what you really need to do is you need to factor. Factor could mean two things here. What I notice right off the bat is factoring this means let's rip out an x. So 0 is going to equal x. Once I pull an x out of that, I'm left with x squared minus 2x plus 1. And then I take a look at that, and I notice, I could factor that further. Two numbers that add up to 2, negative 2, but multiply out to negative 1 are negative 1 and negative 1. And you might look at that and say, those are the same. I'm going to leave it like that. You could have written out x minus 1 squared if you wanted to, but I'm going to leave it like that because it doesn't make a difference. Now that I have something times something equals, or times something equals 1, that's zero product property thoughts. And zero product property says if you multiply several things together and it equals 0, you set each object equal to 0. I have 3 things. So x is going to equal 0, x minus 1 is going to equal 0, and again, x minus 1 is going to equal 0. So you're already done. All I have to do is just add 1 to both sides, and most of you could have done this in your head and didn't have to do any work. Now we get x equals 0 and x equals 1. Those are my 2 answers, but I'm going to add a little sauce to this. Since 1 is technically used twice, I'm going to say that the multiplicity is 2. Whenever you use the same answer 2 times, you say multiplicity is 2. Or if it's the same answer 3 times, multiplicity is 3. That'll come in handy when doing pre-calc stuff. But I technically have 3 answers, 0, 1, and 1. Find the zeros of f of x equals x to the 4th plus x squared minus 12. Whenever I'm asked to find the zeros, I set f of x equal to 0 and then go from there. Now, usually when you have a polynomial, you're going to have to solve by factoring, all right? You might look at that and say, how am I going to factor that? Well, I'm going to say that that kind of looks like it's potentially a quadratic. So if I let a equal x squared, I can now say that this is the same as a squared plus a minus 12. Then I look at this and say, I can factor that. 2 numbers that add up to invisible 1 and multiply out to negative 12 are going to be negative 3 and positive 4, and you are absolutely correct. So a minus 3 and a plus 4. But I'm not done yet, because a is not in my original problem. It's x that's in my original problem. So a is x squared, so x squared minus 3, and x squared plus 4. Now this requires the zero product property. The zero product property says if you multiply 2 or more objects and it's equal to 0, you set each part equal to 0 like so. So I'm going to do that over here. I'm going to say x squared minus 3 equals 0, and x squared plus 4 equals 0, and solve each one of those individually. add 3, x squared equals 3. Take the square root of both sides, don't forget your plus or minus, and x is going to equal plus or minus the square root of 3. That's one potential option. Over here is going to be a little bit grosser but nicer at the same exact time. You'll see what I mean. When I subtract 4, x squared is going to equal negative 4. Square root both sides. Don't forget your plus or minus. The square root of a negative number is I, and the square root of 4 is 2, and so we get plus or minus 2i. So my 4 answers, yes, 4 answers, are going to be x equals positive root 3, negative root 3, and positive 2i and negative 2i. Write a polynomial function of least degree with integral coefficients that has the zeros 3, 2, and negative 2. You might be wondering, what does this mean? Let's kind of work backwards for a second there. If we're doing a factoring problem and it equals 0 and you get something like x plus 5, x minus 4, whatever equals 0, you would look at this and say, all right, well, one of my answers, since that's just a no number in front of x, one of my answers is negative 5. And another one of my answers, since there's no number in front of x, is 4. Hooray! You're right. This is working backwards. If the answer is negative 5, that means there must have been a factor that was x plus 5. So if an answer is 3, that means there must have been a factor of x minus 3, the opposite. If an answer was 2, that must have been a factor of x minus 2, the opposite. If an answer is negative 2, there must have been a factor of x plus 2, the opposite. So that is my polynomial in factored form. Now, just because I'm not sure what your teacher might want, if this was me, I'd be okay with that. But let's multiply this out. I don't want to, but let's multiply this out. This is the most basic answer. Okay. Now multiplying this out means you would FOIL first. So x squared minus 2x minus 3x plus 6. Okay. That's parentheses number 1. Right? Then you have, let's combine like terms, x squared minus 5x plus 6, x plus 2. Let's FOIL that guy out or distribute that guy out. X squared times x is x cubed. X squared times 2 is 2x squared. Then we've got minus 5x times x, which is minus 5x squared. Minus 5x times 2, which is negative 10x. Then you've got 6 times x, which is 6x. 6 times 2, which is 12. That equals 0. And then what we'll do is we won't make it 0 anymore. We'll call it f of x now, just because. Combine like terms. X cubed is all alone. 2x squared minus 5x squared is minus 3x squared. Negative 10x minus or plus 6x is plus 4x. Nope, minus 4x. That was a close one. Minus 4x, and then equals 0. And of course I made like a little, not equals 0, oh my gosh. That little mark is throwing me off. Why did I put equals 0? It should be plus 12. Ugh, ugh, ugh. That's why you guys love me, because I make mistakes. I mean, Maya the Cyrus once said it that everybody does that, so why not me? Thanks for watching, like and subscribe. Evaluate f of a equals a cubed plus 3a squared plus 2a plus 8 at a equals negative 3. Let's be all proper. F of negative 3 is going to equal, now let's replace every a with parentheses negative 3, parentheses negative 3. So negative 3 cubed plus 3, that was a close one, it's like an emo 3, negative 3 squared. 2 times negative, because of the hair, because of the emo looking hair. Maybe I can just see it, maybe you can't, maybe nobody watches these. But anyway, this is me replacing every a with parentheses negative 3. PEMDAS says we're going to do negative 3 times negative 3 times negative 3, which is negative 27. No parentheses needed, but I did it anyway. Negative 3 squared is 9, plus 2 times negative 3 plus 8. The multiply divide part of PEMDAS says that the next thing that I want to do is multiply these guys. So 27, multiply these guys, minus 6 plus 8. God is good. These guys cancel out. And you are left with f of negative 3 equals 2. Is the given binomial a factor? Well, a binomial is a factor if the number that makes this expression equal 0 makes this guy equal 0 as well. So if I were to subtract 6 from both sides, that magic number is going to be negative 6. All right, so if I were to plug in negative 6 into that guy, am I going to get 0? If so, the answer is yes, and if no, the answer is no. So let's do some math. Negative 6 to the 5th, holy crap, I have no clue what that even is, plus 6 times, although I may not have to know what that is if I have my trickeries, which I do, to the 4th, sorry, minus 3, negative 6 squared, minus 22, negative 6, minus 29. Now here's my trickery. Negative 6 times negative 6 times negative 6 times negative 6 times negative 6 is some negative really big number, okay? I'm not going to throw it into a calculator. Negative 6 to the 4th times 6 is going to be the same as positive 6 to the 5th, so this is going to be the same number, so these guys cancel out, no calculator needed. Now that's going to be minus 3 times 36, minus 22 times negative 6 is going to be plus 132, I believe, minus 29. Negative 3 times 36 is negative 108 plus 132 minus 29. I'm going to tell you right now, it's not looking good. 132 minus 108 is going to be 24. 24 minus 29 is negative 5. Negative 5 is not equal to 0. So is the binomial a factor? The answer is a big fat no. Divide using long division. Now when I set up polynomial long division, here's my factor. Okay, here's my dividend. And before I even do that, make sure everything's in order. Make sure there's no p's missing in between, because if there was, I'd have to put like whatever, 0p squared or whatever it is, but no p is missing in between. So p to the 4th plus 5p to the 3rd minus 11p squared minus 25p plus 29. And then we begin the horrible process that is polynomial long division. P times what is p to the 4th? P times p cubed is p to the 4th. Take that p cubed and multiply it to the entire factor. P to the 3rd times p is p to the 4th. P to the 3rd times 6 is 6p cubed. That's positive. Now, we're going to subtract the entire row, which means flip the signs of everything. So you become a minus and you become a minus. You will always cross out. And 5p cubed minus 6p cubed is negative p cubed. Drop down negative 11p squared. Repeat the process. P times what is negative p to the 3rd? Minus p squared is. So you take that minus p squared and you multiply it to the factor. Negative p squared times p is negative p to the 3rd. The same thing here, that will always happen. Negative p squared times positive 6p is negative 6p squared. Subtract the entire row, which means you flip the signs of everything. You will always cross out. And negative 11p plus 6p squared is going to be negative 5p squared. Drop down the minus 25p and repeat the process. Like and subscribe. P times what is negative 5p squared? P times negative 5 is negative 5p is negative 5p squared. So multiply negative 5p to p. That becomes negative 5p squared. Multiply it to 6 as well. So minus 30p add the entire row or subtract the entire row, which means flip the signs of everything. You will always cross out. Negative 25p plus 30p is 5p. Drop down to plus 29. Repeat the process one more time. We're running out of space, so thank God we're almost there. P times what is 5p? 5. So multiply 5 to 5p, so you get 5p. Multiply 5 to 6, which is 30. subtract the entire row, which means you flip the signs of everything. So minus, minus, you will always cross out, and this gives you -1. So I don't like to say remainder -1. I like to say -1 over p plus 6. Whatever that number is, whatever your remainder is, it's going to be plus that number, or in this case minus that number because it's a minus sign, over the factor. So our answer is going to be this guy up here. Yeah, look at that. Isn't that nice? Divide using synthetic division. First off, before we do synthetic division, we have to make sure everything's in order and there's nothing in between missing here, so that's good. Then we take our factor, we make a little box, and we put the number that makes this guy equal to 0 inside of it. Since the opposite of 8 is -8, and -8 is going to go inside that box. Now in this much larger box is going to be the coefficients of the polynomial that we're dividing b plus 8 from. So 6, 53, 32, -61, and 19. 6, 53, 32, -61, and 19. Okay, step number 1, always drop down the first number. Okay, take that number, multiply it to your root, and then put it under here. So 6 times -8 is -48. You add these two numbers up, which is going to be 5 in this case, and repeat. 5 times -8 is -40. 32 plus -40 is -8. -8 times -8 is +64. -61 plus 64 is +3. 3 times -8 is -24. 19 plus -24 is going to be -5, and that's going to be our remainder. So how do we build our answer from this? Well, you go from the right side of the non-remainder numbers and start attaching your variables that we used. We used b. So for 3, attach nothing. That was positive. For -8, attach a b. For +5, attach a b squared. And for +6, attach a b cubed. Now this remainder is going to be whatever our factor is as a denominator, and then we add that remainder to it. So instead of saying plus -5, I'm just going to say -5 because it looks better. So that, ladies and gentlemen, is synthetic division. State the number of complex zeros and the possible number of real and imaginary zeros. All right, well, whenever you're asked to state the number of complex zeros, what you do is you look for the highest degree attached to a variable, which is 2. That tells you how many complex zeros there are, so we're going to say 2 complex zeros. Now, before I answer the next part, let's think of this logically. All right, real zeros are places where my graph crosses the x-axis. This is a parabola. Now, I'm going to pretend I don't know what this guy looks like, but let's just say it looks like that. Okay, let's just say it looks like that. Right now, at this very moment, my parabola does not cross the x-axis, which means it would have 2 imaginary zeros. If at this moment it does, pretend, that little arrow, at this moment it crosses twice. So with problems like this, whenever you have an even degree, you have one of two options. You're either going to have option number 1, 2 real zeros and no imaginary zeros. I forgot how to spell imaginary. That's a G, math. Or you can have 0 real numbers and 2 imaginary. And if this was to the 4th power, we would kind of, do a combination or whatever. But that's what we deal with when we have these types of problems right here. Fun stuff. State the number of complex zeros and the possible number of real and imaginary zeros. Now, looking at this guy, I notice that this is a 9th degree. That's awful. So I'm not going to draw that out or pretend to draw that out. No thanks. But what this tells me, though, is that tells me how many complex zeros there are. Now, this is the way that This is the way that these guys work. You will only, if you have imaginary zeros, you can only have an even amount. So what you do is you start with the bottom at how many possible imaginary zeros starting at 0. So we will say 0 imaginary. And just to be lazy, we'll let I be imaginary. If you're going to have 0 imaginary numbers or zeros, that leaves you with 9 leftover reals. Okay, and then you work your way up by even numbers. So that's a possibility. Here's another possibility. 2 imaginary, and let's just do this. You could have 2 imaginary, you can have 4 imaginary, you can have 6 imaginary, and you can have 8 imaginary. Okay, you can only have an even amount of imaginary numbers all the way up to the number of complex numbers that you have. Now that I said that we had 2, 4, 6, and 8, we subtract these numbers from 9 to find out how many possible reals we have. So if 2 of these are imaginary, that leaves us with 9 reals. If 4 of these are imaginary, that leaves us with 5 reals. If 6 of these are imaginary, that leaves us with 3 reals. And if 8 of these are imaginary, that leaves us with 1 real number. So we have 5 possibilities: 0 imaginary and 9 reals, 2 imaginary and 7, 4 imaginary and 5 reals, 6 imaginary and 3, and 8 imaginary and 1 real. And again, that's because this graph is going to look something like this, blah, 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 all those bumps. So at some point, this will cross the x-axis, but we just don't know how many times it will cross the x-axis. Fun stuff. Write a polynomial function of least degree with integral coefficients that has the given zeros. Okay, first things first. These are all imaginary, but take a look. I'm only giving you 3 of them, right? You have to have a total of an even number of imaginary zeros. I have 2i and negative 2i, which means these guys go together. I have 2 plus 2i, but you know what? I don't have its conjugate. So I have to fill in the blank here by saying you are 2, that was a close one, 2 minus 2i, its conjugate. Now, whenever we find out the original function with the given zeros, we write out our parentheses, and we're going to have 4 of them. Okay, and our parentheses are going to have x's in them, like so. And then the numbers that follow are going to be the opposite of what we're given here. So u would be minus 2i. U would be plus 2i. U would be minus 2 plus 2i in parentheses. U would be minus 2 minus 2i in parentheses. And now it's a matter of just kind of cleaning things up. X minus 2i, x plus 2i, distribute the negative, x minus 2 minus 2i, distribute the negative, x minus 2 plus 2i. And if you had a death wish, what you would do is you would factor this out or FOIL this out a bunch of times, but I'm not even close to thinking about doing that because I don't want to. There you go, that's how it's done. Find the remaining zeros if x equals negative 5 is a 0. So I'm giving you right now f of x equals x cubed plus 9x squared plus 23x plus 15. I have to find out the rest after I get rid of negative 5. So let's do synthetic division. Okay, we are going to use that root, negative 5, and we're going to drop down the coefficients 1, 9, 23, 15. And what this does is this is going to give me the remainder after I divide out the factor x plus 5, knowing very well that negative 5 is a 0. So synthetic division has me drop down the first number, so drop it down, 1. 1 times negative 5 is negative 5. 9 minus 5 is 4. 4 times negative 5 is negative 20. 23 minus 20 is 3. 3 times negative 5 is negative 15. These guys become 0 as well. It should, because if it is a factor, that should become 0. What this gives me is this gives me the leftover polynomial 3, positive 4x, and invisible x squared. Now those are both positives, so there you go. Now I have to find the remaining zeros. So we can set that equal to 0 and factor. So let's bring it up here. Think of two numbers that add up to 4 and multiply out to 3. X plus 1 and x plus 3 do just that. Set it equal to 0. And the opposite of these numbers are going to be -1 and -3. So the remaining zeros are going to be -1 and -3 after I know that it's already -5. State the possible rational zeros for each number. This is called the rational root theorem, and it's hell. What you do is you label the last term's coefficient, which is always going to be a constant, p, and the first term's coefficient, label that q. Now you find all the factors for each of them, all the factors that make up p and q. So the factors that make out 4 are going to be 1, 2, and 4. The factors that make out 25 are going to be 1, 5, and 25. Then what you do is you list out all the possible factors that make p over q, the plus or minus p over q. So let's do the 1 and the p first, and then do 1 over 1, 1 over 2, 1 over 4, and go in that order. So positive or minus 1 over 1, positive or negative 5 over 1, positive or negative 25 over 1. Now let's do the 2's. Positive or minus 1 over 2, positive or minus 5 over 2, positive or minus 25 over 2. Last but not least, we've got over 4, so positive or minus 1 over 4, positive or minus 5 over 4, and positive or negative 25 over 4. Now simplify when you can and get rid of any duplicates, which I don't think we're going to see duplicates, but always try to get rid of them. So 1 over 1 is just 1. Positive or negative 5 over 1 is 5. Positive or negative 25 over 1 is 25. So far no duplicates. Positive or negative 1/2. Positive or negative 5 halves. Positive or negative 25 halves. No duplicates yet. Positive or negative 1/4. Positive or negative 5 quarters. Positive or negative 25 quarters. No duplicates at all. Okay? 18 possible options. Ugh. Describe the end behavior in limit notation. What we have here is a cubic with a positive leading coefficient. I like to call this a Drake cubic. Why? Because when graphed it starts from the bottom and now it's here. So to write that out in limit notation is we have two possibilities. That is the limit as x approaches negative infinity. The limit as x approaches negative infinity has my graph going downward. So the limit as x approaches negative infinity of f of x is also going to be negative infinity because as I move to the left, my graph goes down. Now, as I move to the right is going to be my limit as x approaches positive infinity. As I move to the right, my graph goes up towards positive infinity as well. So the limit as x approaches positive infinity of f of x is also going to be positive infinity. And that is my limit notation and behavior stuff. Very important for pre-calculus, very important for regular calculus. Describe the end behavior in limit notation. What we have here is a quadratic with a negative leading coefficient. So I know it's going to look like u. Now, to write this out in limit notation, I have two options. As I move to the left, I write this out as saying my limit as x approaches negative infinity. While it's moving to the left, my graph is moving downwards. So my limit as x approaches negative infinity of my function f of x is moving downwards towards negative infinity. Now, as my graph moves to the right, that's me saying the limit as x approaches positive infinity. As I move to the right, I'm also heading downward. So my limit as x approaches positive infinity of my function f of x is also negative infinity. Both of them are going downward as I move to the left or move to the right without bound. Okay, so limit notation is very important for calculus, very important for pre-calculus. Know it, love it, it's good stuff. Describe the end behavior in limit notation. This is a quintic, degree 5, and the leading coefficient is positive, which means it's going to look something like this. Exactly like that? No, but something like that. Now, I'm going to write out my limit notation, which means I have two options. As I move to the left, we write that out as the limit as x approaches negative infinity. As x goes to the left is the limit as x approaches negative infinity. Okay, now my function is called f of x. As I move to the left, my graph is going downward. So as I move to the left, my function is also going to negative infinity. So the limit as x approaches negative infinity of f of x is also negative infinity. The other limit that I write out is the limit as f of x approaches positive infinity. As I move to the right, my graph is also moving up. So the limit as x approaches positive infinity of f of x is also positive infinity because as I move to the right, my graph is moving up. So that is how you do that guy right there. Describe the end behavior in limit notation. We have ourselves a quartic function with a negative leading coefficient, which means our picture is going to look something like that. Exactly like that? No, but something like that. Now, as I move to the left, we write that out as the limit as x approaches negative infinity. As I move to the left, my graph is moving downward, which means my limit as x approaches negative infinity of my function is also negative infinity. Similarly, if I wanted to find my other limit, I would say the limit as x approaches positive infinity. The limit as x approaches positive infinity of f of x is going to equal negative infinity. So as I move to the right, my graph is also moving down. And that's the end behavior in limit notation. Sketch using zeros and multiplicity. All right, so what I need to do is I need to find out my zeros first and what the multiplicity of each one is. That'll give me an idea of what a sketch is. Before I even do that though, this is what I recognize. This is a quartic with a negative leading coefficient. So my graph is going to look something like that. Exactly like that? No, but something like that. Now I need to find out the zeros. So the way I find out my zeros is I set that equal to 0 and factor as much as I can. Let's factor out a negative x squared. When I factor out a negative x squared, that leaves me with x squared minus x minus 2. Now we factor what's left over here. I have negative x squared. Two numbers that add up to negative 1 and multiply out to negative 2 would be x minus 2 and x plus 1. Now what I'm going to do is I'm going to list out my zeros and its multiplicity. Okay, if negative x squared is equal to 0, that gives me a 0 of 0 with a multiplicity of 2. That's going to be very important. This gives me a 0 of 2, its opposite, and this gives me a 0 of negative 1, its opposite. Now what I'm going to do is I'm going to use those zeros and that information right here to make what's called a sign graph. Okay, I'm going to make what's called a sign graph. On this sign graph, I have my three zeros in order, negative 1, 0, and positive 2. Okay, now what's very important is whenever the multiplicity is an even number, what happens is my graph as I draw it out ricochets off of the x-axis. This axis, the x-axis right here. When my multiplicity is regular, it goes through. So I know that my graph is going to look like this. Okay? I know my graph's going to look like that. So since it goes through negative 1 first and the multiplicity is 1, it's going to go through that line like this. Now it's going to come back down, and this is very important. If it's going to go through 0, the multiplicity would have to be 1. But the multiplicity is 2 here, which means what's going to happen is it's going to bounce right off. It's going to come back up and go through the 2. And when I say through the 2, I actually mean through the 2 and not next to it. So check this out. No problem. So what happened is the reason why it goes through 2 is the multiplicity is 1. The reason why it bounces off to 0 is because the multiplicity of 2. And the reason why it goes through -1 is the multiplicity is 1. So a sketch of this graph would look like this. Okay, it goes through 1, bounces off. Holy cow, that looks bad. Where it goes through -1, bounces off of 0, goes through 2. Now the reason why this bump is a little higher is because there's more space between the 0 and the 2 than the -1 and the 0. But if I could actually draw stuff out, this would be a much smoother looking curve, but this is a general idea of what it'll look like. Time to use the binomial theorem. First things first, before we do the binomial theorem, we have to create what's called Pascal's triangle. Now this is going to be a degree of 5, so we need to build 6 levels of Pascal's triangle. Level 1 is a 1, level 2 is a 1 and a 1, and then 3 on out is going to be the sum of the previous numbers right above it. So 1's on the outside, 1 plus 1 is 2, 1, 1's on the outside, 1 plus 2 is 3, 2 plus 1 is 3, 1 on the outside. So 1, 2, 3, 4. I need 2 more rows. So we got 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1 on the outside, and then 1, 1 plus 4 is 5, 10, 10, 5, 1. Now, we are focusing on that row there. Whenever you build Pascal's triangle and you're trying to do binomial theorem, it's going to be 1 plus the amount of rows that you want. And once you get to that 1 plus 5, or in this case 6th row, we have ourselves coefficients. So let's go over here and build our coefficients. 1, 5, 10, 10, 5, 1. Now what we do is we label you A and B, right? And you're going to be 1. Now I'm going to start with the A's, work my way down, and then do the B's. Okay, the A's are going to be a to the 5th power all the way to the left, whatever that power is, a to the 5th, and then work your way down. A to the 4th, a to the 3rd, a squared, a, the last one doesn't have one. Then we're going to go in reverse. B to the 5th over here, b to the 4th, b to the 3rd, b squared, b, nothing over there, plus signs in between. Now we plug stuff in. So 1, x to the 5th, plus 5, x to the 4th, 3, plus 10, x to the 3rd, 3 squared, plus 10, x squared, 3 to the 3rd, plus 5, x to the invisible 1, 3 to the 4th, plus 1, 3 to the 5th. Okay, do some math. 1, x to the 5th, plus 5 times 3 is 15, x to the 4th, plus 10, x to the 3rd times 9, plus 10, x squared times 27, plus 5x times 81, plus 1 times 243. That 1 is not necessary. X to the 5th, plus 15, x to the 4th, plus 90, x to the 3rd, plus 270, x squared, plus 420, 405. Oh boy, please don't leave any comments. Plus 243. Yeah, please don't leave any comments on that second to last number that I said incorrectly. Thanks for watching though. All right, binomial theorem. In order to do binomial theorem, we have to go over here and build Pascal's triangle. And we're going to make as many rows as that degree is plus 1. So Pascal's triangle, first row is 1. Second row is 1 and 1. The third row is going to be the sum of the previous ones. Ones are always on the outside. 1 plus 1 is 2. 1's on the outside. 1's on the outside. 1 plus 2 is 3. 2 plus 1 is 3. 1's on the outside. 1, 2, 3, 4. I need one more row. 1's on the outside. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1's on the outside. That's going to be the row that I'm focusing on. That number, or those 5 numbers, are going to be the coefficients for our expansion. So 1, 4, 6, 1. Now, we label U A, and we'll label U B. Okay? Start with A, write out A to the 4th power, whatever power that is, and work your way down. A cubed, A squared, A nothing. Do the same thing with B, and work your way down, but go from the right. B to the 4th, B to the 3rd, B squared, B nothing, plus signs in between. Now we plug stuff in, and then we'll do some math. 1 times 4y, because A is 4 and y to the 4th, plus 4 times 4y to the 3rd times b, which is x, plus 6 times 4y squared times b, which is x squared, plus 4 times a, which is 4y, times b, which is x cubed, plus 1 times x to the 4th. Okay? 1 times 4 to the 4th power is 256, times y to the 4th power is y to the 4th, plus 4 times 4 to the 3rd power is 64, y to the 3rd power, x, plus 6 times 4 squared is 16, y squared, x squared, plus 4 times 4, I could do that right now, 16y, x to the 3rd power, plus 1, x to the 4th power. So that 1 there is useless. So 256, y to the 4th. 4 times 64 is also 256, y to the 3rd, x, plus 6 times 16 is going to be 96. Y squared, x squared, plus 16y x cubed, plus x to the 4th. And I think everything is nice and clean. All is well. Everybody's happy. Thanks for watching. Like and subscribe. Binomial theorem.